What is our inverse operation of addition?
Subtraction.
Subtraction.
Oh.
Wow.
Subtraction.
All right, so we got subtraction for addition. What about division? Okay. Multiplication. Division. Good. And our last one.
Addition.
So good. These are our inverse operations for our four main operations. We could have thrown in exponents or radicals in there as well, but won't worry about those for today. Those are inverse operations. They're always the operations that cancel the other operation out. So addition is canceled out by subtraction, multiplication is canceled out by division, so on and so forth. So when we talk about the word inverse in mathematics, what do you think that means specifically?
Opposite.
Opposite, good.
Opposite.
It's like reverse.
So opposite. So whatever the opposite operation is, or whatever the opposite of whatever you need, we use inverse for that. Good. So today, in algebra, we're going to talk about inverse functions. So these are essentially opposite functions. So you have one function that does something. We're going to look at what's the function that sort of undoes that, or does the opposite of that function. So before we can talk about inverse functions, though, we have to think, once again, what's our definition of a function? What does it mean for something to be a function? So every input has one specific output. So 2, 3, however many weeks ago we learned this. We talked about how functions, their definition determine what was a function and what wasn't a function. Every input, Joey, let's have a seat, has one specific output. So as long as that function, we would draw those like circle maps, and you made sure all those lines went to one specific one. You made sure 1 wasn't going to 2 and 7. That was how we determined whether something was a function. So we're going to use this in helping us to determine what is an inverse function. Joby, AJ, let's focus, please. So for a function, every input has one specific output. If we're talking about an inverse function, we're going to switch those inputs and outputs. So we're doing it backwards. So basically, all those outputs now have a specific input. So for example, looking at those maps that we used in the past, here's my function. So if A is going to 3, B is going to 1, C is going to 2. If I was going to look at the inverse of this function, I would switch those. So 1 now goes to B, 2 now goes to C, 3 now goes to A. Everything is just backwards. Are we okay with that for the moment? Okay. Jody, you're shaking your head. Do you have a question? Okay. So today we won't focus on specifically why we're using inverse functions. That's going to be something we're going to focus on Wednesday because who's in here tomorrow actually? Let me ask that. Just Sage? Okay. So we're going to focus on why we use inverse functions and like what specifically we can show with inverse functions on Wednesday. Today we're just going to learn how to find inverse functions and where do we get them. No.
She said she's really sorry.
Okay, thank you. Let me fix that really quick. Which one is it? Okay, so let's keep talking about inverse functions. So with our inverse functions, we're taking that input and we're taking that output and we're switching them. So your x is now your y is now your x. If you were to look at a graph of these functions, in order to figure out what the inverse function is, you could just look at each point and switch the x and the y of that coordinate, and that would help you plot your inverse function. We'll talk about that more on Wednesday as well. But just given a random function, our goal today is to determine how can we find the inverse of that function. So what is the function that would sort of cancel this function out, or is the opposite of this function? So I start off with f of x equals negative 2x plus 4. So we said the definition of an inverse function, you take that input and output and you switch them. So before I can do anything to this, I'm going to change it to a little bit more manageable format. So rather than being f of x, I'm going to make this y. So once again, when we were talking about functions, we said have f of x and y. They're the same thing. They represent the same thing. It's just two different ways of writing the same variable. So I have y equals negative 2x plus 4. This is my function. If I want to find the inverse of this, we said the inverse is switching my input and output. What's my input for this function? What do I represent as the input? So the input is always going to be our x. It's what we substitute into that function. What's the output? My y. Always the answer, what comes out when I input something in. So as an inverse function, I need to switch my input and output. So in order to solve for an inverse function, we're going to switch these two. So I'm going to rewrite my function. Rather than being y equals negative 2x plus 4, I'm going to rewrite it as x equals negative 2y plus 4. And so whenever you're looking for an inverse function, rewrite it in y equals, and then switch that location for your x and your y. So now we have x equals negative 2y plus 4. In order to figure out what this inverse function actually is, we can solve for y. So normally we always have y equals something. We want that same thing. We want y equals. But right now we have y in the middle. So we're going to have to do our inverse operations, work backwards, to be able to get it to be y equals whatever the function is. So it might seem kind of confusing on how to get to an inverse function at first. But if you know your inverse operations and you can do your little algebra, they become pretty easy. So we want to get y by itself, just as if you were solving for x. We want to solve for y now. So in order to get y by itself, I need to break sort of the outside. AJ, let's go back here, please. You can look later.
I should have had it. Go ahead.
So, your dog. We need to break the outside down and work till we get just to the inside of the y. So I need to work, what's the farthest most on the outside? That 4. So I need to get rid of the 4 first. I'm going to subtract 4. And so x minus 4, are these like terms? No, so I can just rewrite that as x minus 4. I can't do anything, I can't combine them at all, because they're not, one's a variable, one's a constant. So my 4's cancel out, I have x minus 4 now, so that equals negative 2y. So I have negative 2, but what's that negative 2? Is it being added or multiplied by my y? It's being multiplied. So in order to do the inverse of that, I need to divide by negative 2. So that means I have to divide everything on the left side of my equation by negative 2. I'm not just dividing the x, I'm not just dividing the negative 4. I have to divide both of them. Everything is being divided by 2. So what number is in front of that x? A 1. Even when there's not a number there, it's really 1. So when you're dividing multiple things by something, if they're added or subtracted, we can split them up. So I can rewrite this as 1x divided by negative 2 minus 4 divided by negative 2. And this is going to equal y. So we have y by itself. All we need to do is just simplify that left side a little bit, and then we'll have our function. So 1 divided by negative 2, I'm just going to leave that as negative 1/2. You could put it as negative 0.5 if you wanted, if you like decimals, but I'll just leave it as a fraction for now. 4 divided by negative 2. 4 divided by negative 2. 2, negative 2. But we have a negative, negative, so that's going to make it a positive 2. So negative 1/2 x plus 2, that's going to be the inverse function of my original. Y equals negative 2x plus 4. So I'm going to, once again, rewrite this. I'm going to make it a little bit nicer and put my y back on my left side. Ooh, that's not fun. And then, because we're calling it functions, we're talking about functions, I want to put it back in function notation. When we talk about inverse functions, we use that same letter, so I'm still going to use f of x. But in order to show that it's an inverse function, I'm going to put a little negative 1 at the top. That negative 1 symbol represents inverse in mathematics. So this is going to be inverse function, and it's going to equal negative 1/2 x plus 2. And that is my final thing that I'm looking for. That was my inverse function of my original function. So in order to sort of recap what steps we took in order to get here, we started with our original function. We rewrote it into y equals. We switched that x and the y. We switched the location. And then we solved for y. We inversed to 4, inversed our negative 2, and then we got negative 1/2 x plus 2 equals y. We rewrote that back up here, and then we just wrote it as inverse f of x equals negative 1/2 x plus 2. Are we okay with the steps we took to get there? Kind of. We can do another example as well. Are you still copying some of them? Okay. All right. So let's see this again. Boys. So we're going to find the inverse function. Dominic, action.
You stole my pencil, it's not even there.
Right.
I stole myself.
It's your
Alright.
Give me this one back. Children. So we need to find the inverse function. We have f of x equals 3x plus 2. So once again, rewrite it in terms of y equals. And then we're going to switch that x and the y. So all I'm going to do is just where the x is, I'm going to put a y. And where my y is, I'm going to put an x. So I switch their location. And then we just solve it backwards. Start solving for that y. So just like in solving equations, first thing you want to get rid of is that constant. So I'll inverse my constant by subtracting 2. So that gives me x minus 2 equals 3y. In order to solve for that y, I need to inverse my coefficient, so I need to divide by 3. Once again, we come to that situation where we have to divide everything by 3. And as long as they're being added or subtracted, I can split them up into 2 divisions. I can do x divided by 3, or 1x divided by 3, minus 2 divided by 3. So 1x divided by 3, I'm just going to rewrite that and keep it as a fraction as 1/3 x minus 2/3 equals that. Are we okay with this so far? So I rewrite it. I'm going to rewrite it back up to the top. I'm going to put my y on my left because I like it over there. And then it was minus, I believe. Yes. So last step, I just need to change it from y equals to f of x. I want to make it a function. But it's an inverse function, so I'm going to put that -1. My final solution is inverse f of x equals 1/3 x minus 2. Are we okay with the steps? Once again, rewrite it as y equals, switch that x into y, solve for y, do all those inverse operations to solve for y, rewrite it as inverse f of x equals. I'll give you an example as soon as that copy done.
Yeah, sure looks good on you. Yeah, good. That's okay.
All right, take a moment, see if you can find. Okay, let's talk about this. So step number 1, we changed it into y equals 4x minus 12. We then switched the locations of that x and the y. So we have x equals 4y minus 12. We then needed to start to solve for y. So we added 12. But x and 12, these aren't like terms. So we had to leave it as x plus 12. And that equals 4y. In order to get that y by itself, you then need to divide by 4. And we have to divide each of these by 4, x and 12. So x divided by 4, that just leaves us with 1/4 x, because it has a 1 in front of it. 12 divided by 4, that's 3. So we then have 1/4 x plus 3 equals y. Last step, we just need to rewrite this function in terms of a function. So we want to have that f of x in there. But because it's an inverse function, I'm going to put my -1 to show that this is an inverse. And so inverse function is going to be 1/4 x plus 3. And that is my inverse function of 4x plus minus 12 that I started with. Are we okay with this step we took? Questions, concerns? All right. So this one's going to be a little bit trickier though. Because rather than having a constant, or rather than having an integer, I have a fraction for my slope. So let's walk through this one together and see what sort of changes when I have a fraction instead. So it's going to be y equals 1/4 x minus 7. I switch that x and y. That gives me x equals 1/4 y minus 7. In order to solve for y, first I need to inverse my constant, so I'm going to add 7. So x plus 7, they're not like terms, so I'll just have x plus 7. That equals 1/4 y. So this is where it gets a little bit different. Because typically we would just have a number and we would divide by that number. So we had 4 in the last example, we divided by 4. We had 2 before, we divided by 2. What happens when you have to divide by a fraction now? Divide by a fraction. Multiply by 1. So if I had 1/2 divided by 1/3, let's say. When dividing fractions, don't ask why, just flip the second and multiply. So when dividing fractions, take your second number, your second fraction, and flip it upside down. It's called the reciprocal, taking the reciprocal of that fraction. So if it's 1/3, we're now going to rewrite it as 3/1. And rather than dividing, we are now multiplying these numbers. So when dividing fractions, don't ask why, flip the second, and then multiply. So this is 3. It does rhyme. That's crazy. Yeah. So 3/2. So when dividing fractions, you're really multiplying by the reciprocal. So we want to divide by 1/4 in order to inverse it. What number should we multiply by? we're going to multiply by the reciprocal, so we're going to multiply by 4 over 1, or just 4.
So equals 1.
It would equal 1. And that's how they cancel out. But if I multiply one side by 4, I have to multiply my other side by 4. How would I do this multiplication? Distribute. So 4 times x, do 4x, and then 4 times 7. I don't know what's up with the pen today. It's like dropping dots. So that gives me 4x plus 28 equals y. Last step, I just want to rewrite it in terms of a function. So I'm going to put it as inverse f of x equals 4x plus 28. Just change that y. So the main thing to catch from this problem is when you have to divide by that fraction, if your slope is a fraction and you need to divide by that, multiply by the reciprocal to both sides. So 1/4 became 4 over 1. We're going to multiply that. And so 4 over 1 is the same as 4. So I just multiply by 4. Do you want to see another example of that with the reciprocal? So f of x equals 2/3 x plus 1. Once again, rewrite this in terms of y. So y equals 2/3 x plus 1. Switch your x and your y. X equals 2/3 y plus 1. First step, always inverse that constant. So my constant is the number without any variables. So I'm going to inverse -1, or inverse +1, I'm sorry, by subtracting 1. And this gives us x minus 1 equals 2/3 y. Now we have to come to dividing by our fraction. Once again, dividing fractions, don't ask why. Flip the second and multiply. What was that? It will equal 1 when you divide it and then cancel out. But what number are we going to multiply by in order to be 3 over 2? Good. So you're just going to multiply by the reciprocal, and those cancel out. But if we multiply one side by 3 over 2, I have to multiply both sides by 3 over 2. And once again, we're multiplying everything by 3 over 2, so I need to distribute. So 3 over 2 times x is 3/2 x. 3 over 2 times -1 is minus 3 over 2. And that leaves me with my y. Last step, rewrite it as a function. So I end up with inverse f of x equals 3 over 2x minus 3 over 2. So same steps as before. The only thing different is multiplying by the reciprocal rather than dividing by whatever fraction you have or whatever number you have. All right, I'll give you one to try to work through on your own. That has a fractional slope. So you have f of x equals -1/6x plus 2. See if you can find the inverse to this function.
Is this what we did?
Same thing like you just did in the last problem. Now we just did
That's negative.
yeah, -1/6x. And the negatives are both equal to 5 times 6. Let's see. So, how do you get this to plus 2? Right, that way. So what operates? Subtract. Right, now you need to get rid of this. You did. So 14 first we subtracted. We brought it to we have x plus 1 or x minus 2. We have 1 negative 1. So negative 1. We're going to multiply by the reciprocal. We're going to multiply by negative 1. Flip. Now it's again close to that. But if I multiply with one side by negative 6 1. So negative 6 1 doesn't give us negative 6. We write it final thing? You subtract 1. That would be so in order to get rid of this, what number we and then we'll keep that negative. So we'll put it negative. So multiply this by negative. So our negatives go one. Number 6. So in order to intercept divide divided by negative 1. What number should we multiply? But either inside. Dividing by a fraction. You're essentially dividing. It's equal. I would and Barbara, where's the sign that you like said that? I need to say that it has all the all that. No, post the whole thing because then my butt. I forgot you.
Well, I'm still going to put the video on so we can remember.
Yeah. I need to take care of this today. I didn't help.
So,
I can come here and go.
or yeah. I'm kind of.
Oh, yeah.
Now we are. I just chose not to.